In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light.
I want to try to tie everything together on all these cosmologies, and I'll admit at the very beginning that this is my thoughts, and they're not your thoughts, but I'm just telling you what I think about it all. And obviously I don't expect everybody to agree with me. I'd be surprised if you did. But after looking at all the evidence, looking at the Bible and everything else, this is kind of how I have put it together. First of all, I agree with Dr. Robert Eckel. This is from the book In 6 Days. He is a medical doctor, as I recall, but he comes from, other scientific backgrounds. But he says creation in 6 days is not an intellectual argument that can be won by in-depth and repetitive examinations of the scientific evidence available. You're just not going to win that argument if you look at the science and try to win someone over by trying to argue about the age of the universe. And so I agree with that. It requires faith to believe in the creation. Not that there's not evidence for a creation, not saying that. But if all you do is go to the scientific evidence, you're going to have a big hurdle to overcome. And I don't believe you're going to convert the agnostic to Christianity by beginning with that argument. I just don't. And an unbelieving world will never heed to the things that are more spiritual and to believe. We looked at 1 Corinthians last week. The word of the cross is to those who are perishing foolishness, but to those who are being saved, it is the power of God. Unbelieving world doesn't look at the Bible as the inspired word of God. But this class is all about evidences, and to show that there are evidences of a creation. I think we've done that, and we'll continue to do that. And that there's evidence of design, and there's an evidence of a creator. But there's going to take some faith when it all boils down to it. If you're an apologist, and we know what that word means, apologist doesn't mean you're apologizing for Christ, okay? It means you're arguing, if you will, I want to use that word, arguing from the evidences. So don't take that word to mean apologizing, but the position of the apologist, you still need to have some scientific data if you're going to go that route, okay? If you're not, when you start arguing or talking about some of these things strictly from a biblical point of view, it's going to be hard for the non-believer to follow you, I guess is the right word I'm trying to use here. So you still need these evidences that we've talked about in our class. But the bottom line is, by faith, we understand that the universe was formed by God's command. And bottom line is, it's still the Bible, it's still faith that guides us. But evidences are that the universe at least appears old. There appears to be some age to the universe. And I think probably the biggest reason I say that is the light time travel dilemma. That really makes the universe look old. When stars and galaxies are light years away, in some cases billions of light years away, that gives the appearance of a very old universe. And it's hard to get around that. Now you could choose, as I said last week, to ignore the science. You just say, okay, I know there's evidence there, but I don't care, and that's fine. I have any problem with that whatsoever, if that's someone's approach, because that's what the Bible says. By faith, we believe that the earth was created by God. But that doesn't really work for me. Here's the question: could God have created the universe in 6 days? Obviously. Obviously. These are rhetorical questions, but they're kind of thought questions. Could God have created the earth in 14 billion years? Obviously, he could have. Could he have created it in 10 to minus 43 seconds? Obviously. So, some would argue, why did he take so long? Why use 6 days? Why not just speak it into existence at the very beginning? I don't know, but he did. If you think about it, concept of a week. Where do we get the concept of a week, 7 days in the week? It's not astronomical. It's not based on anything. The lunar months wouldn't work. It's biblical. It's completely biblical. That's where we get the concept of week to begin with. So, but the question isn't how long it could take. I guess the question is, how long did it take? And I believe it took 6 days. But I believe there's ways of understanding why the universe looks so old. So the question is not what God could have done, but what actually occurred. And in my opinion, it may be and probably is that mankind is just incapable of comprehending exactly how all that was done. I don't think we can possibly comprehend it all. I don't think we ever will. We've looked at things and we look at the processes that are going on, but to think that we can actually comprehend how God could have done that in 6 days or 1 billion years or 14 billion years or 10 to the minus 43 seconds, I think in actuality is maybe impossible for us to completely understand it. That's why Hebrews says by faith God created the universe. But I think there is evidence that God used processes. We're not robots. There's processes going on in our body. There's processes that are going on in the universe. There's gravity and there's electromagnetic forces and there's strong nuclear forces and all that. And God used those processes. And I think there's plenty of evidence of that. And I believe that is at least in some way that how man differs from the animals, besides the fact that we're spiritual and we have a spirit and animals do not have the spirit that we have. But Genesis 1:22, I think that encompasses the curiosity that God put in man and the intellect that God put in man that allows us to attempt to discern those processes. For whatever reason, God did that. We have that intellect. And mankind has continued to grow from century or millennium. And if mankind is allowed to go on by God for another millennium, there'll be things that we're doing 1,000 years from now they wouldn't have any conception of right now. Every generation thinks they have all the most modern, has more than any other generation will ever have, and that's just, of course, nonsense. Generations will come and generations will go, but there will be a continuation of understanding these processes. But these processes follow law, and those laws were set up by God. The Bible, in particular, the book of Genesis, was probably written by Moses, as we all know, guided through the Holy Spirit, 2 Timothy 3:16. But it was written for all ages. It was written for men, 3,000 years ago. It was written for men now and everybody in between. And all men during these periods of time had a different level of understanding. Men back 2,000 years ago wouldn't have a concept of electromagnetic force. They just wouldn't have that. We have that now. So it's for everyone to comprehend, but we can comprehend it a little bit differently when we understand these processes. I think that's stating the obvious, but that's true. And though this is my point of view, understanding the light time travel enigma as well as other phenomena, including the older universe, lies, I think, in the domain of the concept of relativistic time, which we've already seen experimentally has been shown over and over to be true. And I think it lies somewhere in that domain. Now, exactly, I don't have all the answers, but I think understanding that lies somewhere in that domain. And I think right now, at least, that white hole cosmology that we talked about last week probably is the best explanation I have for why the universe appears to be so old. And if you recall, the white hole cosmology, if it's true, then stars and galaxies are billions of light years away, thus giving credence, at least, to an old universe, yet they were still created in 6 days. And that sounds contradictory, but the white hole cosmology, written by creationist Russell Humphreys, allows for that. You say, well, they just appear to be 14 billion years away. I don't care if you want to use that word. That's fine. They just appear to be 14 billion years away, but they are 14 billion light years away. You can use the word appear or not. That don't bother me one way or the other. But I believe they can be 14 billion light years away and yet still have been created in 6 days. And again, that sounds contradictory, but using the white hole cosmology at least makes sense. And this is also my opinion. From an apologetic point of view, from an apologist's point of view, I think it becomes somewhat fruitless, maybe counterproductive if you're trying to convert someone to Christianity to try to use the argument that the first day was a literal 24 hours. I don't know what that means because it's relativistic. 24 hours to who? 24 literally ticking hours, because the cosmic clock ticks differently depending where you are in the universe. And I think it'd be counterproductive. And from my point of view, I think you were trying to convert someone to Christ and that turned them off immediately. You may have just lost someone. So I wouldn't begin there. I'm not saying that's not true. I'm just saying I wouldn't begin there. But I believe it can be literally true that the earth was created in 6 days. And that's not a gap theory. That's not what I'm talking about. I'm talking about the concept of relativistic time. So when we start looking at other evidences, and we will in a few weeks, looking at evidences of a young earth versus an old earth, I just want you to know there's evidences for both. Can't say there's evidence that purely determines that the earth is only 10,000 years old. But there's plenty of evidence that it very well may be. But there's evidence for an older universe as well. The problem comes is, and again, as we began the beginning of this very study months ago, whether the earth is 4.5 billion years, which is the current theory, or 10,000 years, there's still not enough time for evolution. This is not an evolutionary thing. This is not an evolutionary thing. How old the universe is, to me, is immaterial to whether evolution could occur or not. There would have never been enough time for evolution to occur, no matter how old the universe is, or how old the earth is. Dr. Elaine Kennedy, who is a young earth scientist, geologist. So if there's a person that's seen the evidences, it would be her. You know, we had a young man here, and I'm blanking on his name right now. He was here last summer that's going into geology. And I asked him some of these questions, how he looks at the data. Of course, he's still beginning in his career, working on his PhD. But Dr. Kennedy has already received her PhD. And she looks at the data, and she points out that the geologic record can be interpreted to support either a long, millions of years, or a short, few thousand years history on the earth. The data can support either one. But it's how you look at that data. And that last slide didn't show up for some reason. It's how you look at that data. It's how you interpret that data that's important. So if you're looking at it already determining that the earth is billions of years old, you're going to look at the data and it's going to fit your concept. It's going to fit your belief. If you look at it realizing that the earth could have easily been 10,000, could be easily 10,000 years old, the data will fit that too. And this week or today we're going to get into the fine-tuning of the universe. And we're going to be looking at some thoughts of Dr. Danny Faulkner. And he's an astronomer. He's an astronomical physicist. A very bright guy. So he's seen evidences for and against as well. But there's some very interesting evidence from an astrophysical point of view of a much younger universe. So let's talk about a fine-tuned universe. That's what we're going to spend this week and next week talking about. In the 16th century, Polish astronomer Nicholas Copernicus was the first one to really, put together the concept that the earth was not the center of the solar system. And I would not say that mankind didn't know that before, but it certainly was not coded. It was not written down. And Copernicus came along, and he was an astronomer, and he finally came up with evidence, and looking at the stars, looking at the moon, looking at the sun, that indeed the earth was not the center of our solar system. It could still be the center of the universe, believe it or not, and not be the center of the solar system. But it certainly is not the center of the solar system in the fact that everything rotates around the earth. We just know that's not true. The moon does, but everything else rotates in our solar system around the sun. And when he did this, it relegated our earth to at least some point to a position of mediocrity. And ever since then, the earth has been looked upon as just a mediocre planet. And there's various words for this. There's actually something called the principle of mediocrity. And then there's the Copernican principle, and then there's the cosmologic principle. These are all the same thing. So when you see either of these three, we're talking about the same principle. And that is that the earth is nothing special. There's nothing special about the earth. It's just another planet. That's the principle of mediocrity, okay? Nothing special about us. No reason it was placed here for any special reason. And if you take that position and you believe in this principle of mediocrity, it's going to lead to several conclusions or predictions, if you want to use the word predictions, and I've listed them here. And the first prediction is that the earth, while it has many light-permitting properties, isn't exceptionally suited for life in our solar system, and you would expect other planets in the solar system to probably harbor life as well. That's one prediction it would make if you say it's just a mediocre planet, nothing special about it. It would also predict that our sun is a fairly ordinary and typical star. And our solar system is also very typical, and we would expect many other solar systems to mirror our own. That's what you would decide if you had believed in the Copernican principle. There should be plenty of other stars that could harbor life, solar systems that could harbor life throughout the universe if the Copernican principle is true. Further, you would expect a lot of planetary configurations that are consistent with the presence of biologic life. How many planets have we discovered so far? It's a lot, not just in our solar system. There's hundreds and hundreds of planets that they've been able to discover outside our own solar system. And you would expect a lot of these planetary configurations to be consistent with life and be able to support life. After all, I think we would all agree, if the Earth wasn't what it is, we couldn't be here today. If we were on a planet that was too close to the sun, like Mercury, probably wouldn't be here today. Too hot. A planet that's too far from the sun, probably too cold, so on. So there should be, but the point is, there should be lots of planetary configurations where you would find a planet similar to Earth, if the Copernican principle is true. It also predicts that variables like the numbers and types of planets and moons have little to do with the existence of life on a planetary system. That really doesn't, the Copernican principle would say that doesn't have anything to do with it. Further on, our solar system's location in the Milky Way is unimportant, and our galaxy is not particularly exceptional either. Even our own galaxy would not be exceptional. There should be lots of other galaxies, and there are millions of galaxies seen through the Hubble telescope, and all these should be able to produce life. And you would predict that with the Copernican principle. And finally, the Copernican principle would predict the universe is infinite in space and matter and time, and that the laws of physics are not specially arranged for the existence of complex or intelligent life. That's what you would predict. So as a result of that, the obvious conclusion would be, if you were a scientist then, there has to be life on other planets, right? You would predict that. And actually, two fellows, one of these you'll know, Carl Sagan, who's passed away now, but he was the guy that was on TV a lot and famous for the billions and billions of years and all that stuff, billions of stars. Frank Drake and Carl Sagan formulated what has been termed the Drake equation. Now, they made this equation up based on a lot of assumed guesses, basically. Made a lot of guesses based upon the Copernican principle. These guesses were all based upon the Copernican principle. And they came up with a startling conclusion that intelligent life was common and widespread throughout the galaxy. Not just galaxies, mind you, but widespread through even our own galaxy. Carl Sagan was even quoted as saying that he expected there was probably at least 1 million planets in our galaxy that was supporting life. So that's the Copernican principle, and you would expect that. So as a result, mankind has sort of accepted this idea that we're not anything special. And so the imagination runs wild, and so you have a lot, I just picked a few here, fictionalized stories, books, films, TV shows, whatever, that are looking to intelligent life. The one on the left was Close Encounters of the Third Kind. Boy, I love that movie. I mean, I know it was fiction, but I did love that movie. Do you remember seeing it? I mean, but what?
Sound, I saw it, the old Alabama theater.
Yeah. It's been quite a few years ago, but it was a good movie, I thought. But what was it all about? It was about intelligent life, the third encounter, or close encounter of a third kind. So we actually get to meet the aliens in that show. 2001: A Space Odyssey. Interesting. Do you remember that show? Now, you got to be older to remember this one, because I remember when it first came out. Stanley Kubrick. Beautiful movie. The music's phenomenal. It uses a lot of classical music. Johann Strauss and others in the show. Interestingly, in the movie 2001: A Space Odyssey, you never see an alien. You never see an alien, but you know what you do see, if you remember the movie. They find a monolith on the moon. Now, 2001 seems like, well, that's ancient history. This movie was written, I think it came out in the late 60s, 68 or 69. So it well predated. Now, some of the things in that movie have come about. Some of the technology that's in that movie we're using now. It wasn't available then. So there was Arthur C. Clarke, who wrote the movie, was somewhat prescient in that sense. But you never see an alien there. But what you see is this perfectly constructed stone with perfect dimensions on the moon. So what did that show the people that saw that? It showed there had to be some intelligent life. Isn't that interesting? That no life, but because of that. And it was beaming a radio signal to Jupiter, but you never actually see the life there. And then there was the movie Contact. Do you remember this movie with Jodie Foster? A very good movie. I mean, I liked it too, but it was all about this next thing called SETI, S-E-T-I. SETI is Search for Extraterrestrial Intelligence, and this is a real thing. We have these radars, I guess you might call them, out across the world. And what are these radars trying to do? They're trying to detect intelligent life. Now, if you remember that movie, Jodie Foster is one of the scientists that's working there. It also had Matthew McConaughey in his early career, playing a preacher of all things. But she's listening to the radio waves, and they predict a pattern. Again, interesting, isn't it? They predict a pattern. Well, that's all they predicted. And this pattern that they were predicting coming in from these radars showed that there was some intelligent life out there. And of course, eventually they build a machine that they're able to go through, I guess, a wormhole or something and find intelligent design. So all that stuff, mankind's imagination has run wild with the concept that there's extraterrestrial life out there, but not only from a fictionalized point of view, but from a scientific point of view. In fact, Drake began all this by sending radio waves out. Frank Drake sent radio waves out, hoping that he would get a response. Now, here's the deal though. If you're sending radio waves out and you've got to go to distant stars, and some of these stars are at least thousands of light years away, how long do you think it would take to get the signal back? Well, we're not going to be around for it, I can tell you that right now. You know, just unless Alpha Centauri has somebody, and there's no evidence that there's life near Alpha Centauri. But that's how it all began. So now, though, instead of sending the radio waves, we're receiving them. And early on, there was some excitement. Woo! We found it. They started receiving some radio waves. We've got intelligent life out there. But it turned out to be these were pulsars. Pulsars are stars that send out radio waves. What an intelligent. There was no pattern to it. So how many patterns do you think they have received since they've started this? And that movie was, how long ago was that? 20 years ago? It's been a while. And so they've been looking for this for a long time. How many patterns or intelligent sources have they received so far? Right, 0. I mean, none. They haven't received them yet. Not that they're not looking, and it doesn't mean, I'm not saying that because they haven't received it, that they won't receive it. I don't know if there's other intelligent life other than us, but the Bible doesn't talk about it. So my belief is there's probably not, but they haven't received any so far. So to me and others, it remains a bit of a puzzle that we have not found evidence to date when supposedly millions of planets in our galaxies contain it. If they've been looking for it, and there's millions of planets in our galaxy, you would have thought we would have heard something from them by now, right? You'd have heard something from them by now. In fact, Enrico Fermi, a brilliant physicist, he was involved at the Los Alamos complex during the World War II. A brilliant physicist. He's no longer with us, obviously, but he came up with something that has been known as Fermi's paradox. And Fermi's paradox is not really a paradox at all if you don't accept extraterrestrial life is out there. But if you accept extraterrestrial life is in the galaxies or in our galaxy, then it is a bit of a paradox. Because he reasoned that if there was millions of planets that supported life, most likely some of that life would be intelligent life, just theoretically if they're out there. More likely than not, some of those would be far advanced from us, more likely than not, if you had millions of planets out there. And more likely than not, they would have been, just if nothing else, for curiosity's sake, would be looking for other people in the galaxy, other intelligent life in the galaxy, right? And more likely than not, we should have heard from them by now then. They would have developed technology superior to ours if their intellect was superior to ours. And they would have been able to contact us. So his paradox was, where are they? Where are they? We should have heard from them by now. And yet Carl Sagan, when he was alive, said that there was probably at least a million planets in our galaxy alone that supported life. So that's a bit of a paradox. It can't be answered. So as a result of this, not really as a result, but now as a result of looking at the evidences, some scientists are beginning to question the Copernican principle altogether, or the principle of mediocrity, or the cosmologic principle. They're questioning that altogether now. Maybe that's really not true. In other words, maybe there really is something special about our Earth. And so as a result of that, a couple of books we're going to look at, and there's been more, but these were the seminal books that were first written. One is called Rare Earth by Peter Ward and Donald Brownlee. And this is what they say. They say in their book that the Earth seems to be quite a gem. It's a rocky planet where not only can liquid, and by the way, to have a planet inhabitable life, you probably need a planet that has rocks, land, not just water, especially intelligent life. But it's a rocky planet where not only can liquid water exist for long periods of time, thanks to the Earth's distance from the sun, as well as possession of tectonic, quote, thermostat that regulates the temperature plates, but where water can be found as a healthy ocean, not too little and not too much. Furthermore, our planet seems to reside in a benign region of the galaxy where comets and asteroid bombardments is tolerable, and habitable zone planets can commonly grow to Earth's size. Such real estate in our galaxy, perhaps in any galaxy, is prime for life and is rare as well. So their deduction was the exact opposite of the Copernican principle, that we're not a mediocre planet, that there's something rare about the Earth. Now, they would not say that the presence of life elsewhere couldn't be possible, but they would say most likely if there was life somewhere else, it would be very rudimentary. And they point to the extremophiles. We talked about that in one class here before. Remember the extremophiles? This is life that can exist at either real hot or real cold environments. Cameron, or I'm blanking on his name now, the guy that wrote the Titanic movie, Cameron McIntosh, is that right? Who? Yes, Cameron Crowe. He's taken off now and really gone into scientific research. And we saw him on a late night show and talks about they've gone to the depths of the ocean where no other vehicles, no other submarines have been able to go. And guess what he found down there? Life, unbelievably. Some of these animals can actually live on the minerals of the rock. That's what they eat, these very rudimentary organisms. So those may be out there, according to Brownlee and Ward, but they won't have reached the point of intelligence because of just couldn't develop that. Then a few years later, I think Rare Earth was published like in 2000, and then Guillermo Gonzalez's book came out in 2004. And Guillermo Gonzalez is also an astrophysicist. Jay Richards is more of a theologian, works with the Discover Institute. And they wrote a similar book called The Privileged Planet, which also stated kind of the same thing, but from a little bit of a different perspective. Interesting, Brownlee and Lee quote Gonzalez in their book, even though it was published before, but he had already done some research along this line, talking about the habitable zones. And Gonzalez and Richard were, their point of view, now the conclusions were kind of the same, that the Earth is rare, it's not just mediocre, but they look at it from a little different perspective in that they say that it's amazing that the Earth seems to be situated in a habitable zone, not only in a habitable zone, but in an area of the galaxy that allows for discovery. If we weren't where we are in the galaxy, we wouldn't see some of the things we're able to see. We wouldn't be able to discover some of the things that we're able to discover. And that seems kind of odd, but it's true. And this is their claim. Our claim is that the Earth's conditions allow for stunning diversity of measurements from cosmology and galactic astronomy to stellar astrophysics and geophysics. They allow for the rich diversity of measurement, much more so than if Earth was ideally suited for, say, just one of these sorts of measurements. The Earth seems to be situated not only for the fact that it allows for life, but it allows for discovery. So, Ward, Brownlee, Gonzalez, and Richards, they understand the uniqueness of the Earth. But their significance is viewed quite differently by them. Ward and Brownlee kind of make fun of the fact that the religious population or community has latched onto their book. That's not their intent of their book. Their book wasn't written so that they were trying to prove God. They were just making a statement, basically, that the earth was rare, because they're not religious people. They're naturalists. So what was the point of their book? I guess the point of their book was to sell books, I guess. But it was also to show that the earth was rare. Gonzalez and Richards, I don't know what their religious affiliations are, but their point was that this smacked of design and that it also smacked of a creator of some sort. So Gonzalez and Richards, design provides just such a tiny explanation here. Think of it this way. If the physical universe were designed so that any observers would find themselves in an environment conducive to many diverse scientific discoveries, then the correlation would be just what they would have expected. Although this evidence might not prove the cosmos was designed, it certainly would, or surely would, confirm it. So their point of view is completely different, although they use a lot of the same data. So let's look at rare earth. We're not going to have time to finish this. There's more to this, by the way, there's more to this lesson than what you've got printed. We didn't have time to print it all out, but that you'll get another next week. Next week, by the way, is not next Sunday, but it's 2 Wednesdays from now. So, factors that make the earth so rare indeed. The earth is situated in a galaxy in the universe that allows for life to exist. That's point blank true. The earth is situated in a type of galaxy, a spiral galaxy, which the Milky Way is, and it's situated in that position in the galaxy that allows life to exist. Now, there are dead zones where life could not exist. And physicists agree with this, by the way. I don't know of any physicist, astrophysicist, that would disagree with this. But there's areas in the universe that you're not going to get life. And they call these dead zones. And I'm going to go through these fairly quickly. But dead zones would include distant galaxies which would not have enough metals for the formation of Earth-sized planets. Earth has to have metal, rock. We have to have it. Any planet would have to have it to support life. Globular cluster galaxies would be too metal poor to have inner planets as large as Earth. In elliptical galaxies, which is ours is not, again, ours is a spiral, elliptical galaxies whose stars are also too metal poor, and small galaxies, as you might guess, would be too metal poor. So most of these galaxies that you see out there would never be able to have life. They're too metal poor. You need metal. Furthermore, if you were at the center of a galaxy, you would also be in a dead zone. So if we were in the center of the Milky Way, we wouldn't be able to have life, most likely, because energetic processes would impede complex life. There's too much energy going on inside the middle of a galaxy, the center of a galaxy. The edges of galaxies, you're too far out, would contain many stars that are there, but again, they would be too metal poor. And then you need, if you had Jupiter, we're going to talk about Jupiter either next week or the week after. Jupiter, it turns out, is very important for life to exist on Earth. If Jupiter wasn't there, we probably wouldn't be here. If God hadn't created Jupiter to be there, we wouldn't be here. But you have to have a planet like Jupiter in your solar system to be effective and have life. And if you had hot Jupiters, Jupiters that were the same size, by the way, Jupiter's about 360 times the size of the Earth. It's huge. And if you didn't have Jupiters, you'd be in trouble. But if you had Jupiters, but they were too close to the sun, we would call these hot Jupiters, and you would drive the planets inward and you wouldn't have life. Planetary systems with gigantic planets in eccentric orbits would produce environments too unstable for life. You have to have the right size planet, and you have to have the right type of orbit. So our Earth does possess rare factors that allow for life to exist and continue to exist. What are those factors? It has the right type of sun, which produces not too much ultraviolet light, the right distance from the star to allow for liquid water near the surface, but far enough to avoid something called a tidal lock, which means the tides only go in one direction, basically. Our Earth is the right size, and it has a very stable orbit. It retains atmosphere and oceans and enough heat for plate tectonics. And if you don't know what that is, we're going to talk about that in depth. Plate tectonics seem to be absolutely essential for life to occur on Earth, and they're real. They're real. Jupiter, we're going to go into this in a little bit more detail, but Jupiter, our distant neighbor, is important because it cleans out comets and asteroids. If we had a bunch of comets and a bunch of asteroids bombarding the Earth, do you think we would be here? No. We do have bits of asteroids in the form of meteorites that do make it to Earth, but they're not big enough to cause a lot of problems most of the time. And so it just happens to be not too close, but also not too far. What does it do? It shields us from those asteroids because of its large gravitational force. Again, it's 360 times the mass of the Earth. Mars. Now, is Mars important? Well, Mars isn't really important for life, but this is from Rare Earth. They opine that it's important in case we need to colonize. We probably could colonize Mars if we needed to. It's close enough, and even though its environment is a little more hostile than ours, we probably could allow it if we needed to do it. And then here's the plate tectonics. Plate tectonics, and we're going to go into great detail, so you don't be worried about copying all this down or knowing what it means, but plate tectonics produce CO2. They build up landmass. They enhance biologic or biotic diversity. And here's a big one. They enable a magnetic field. If we don't have a magnetic field, we wouldn't be around here. We have to have a magnetic field. And they provide a thermostat for the Earth. Very, very important. And our oceans, we briefly mentioned this. Our oceans seem to be just the right size. Not too much, not too little, not covering all the face of the Earth. Plate tectonics, just quickly, if you didn't have plate tectonics, you probably wouldn't have mountains. If you didn't have mountain ranges, what would the Earth be? Underwater. You wouldn't have land if you didn't have those mountains, and plate tectonics allows for that. Our moon, very important. Our moon is very important for life. These all, by the way, go against that Copernican principle. If you've noticed, everything I've said so far is exactly opposite what the principle of mediocrity would say, right? Well, it turns out the moon is very important. We have a very large moon. Our moon is about a third the size of the Earth. That's pretty big. That's big when it comes to moons. But it also just happens to be just far enough. Not too close, not too far. But what it primarily does for the Earth is it stabilizes the tilt of the Earth. The Earth tilts on about 22.5 degrees. If we didn't have that tilt, if we didn't have the tilt in the Earth, life wouldn't be here. And we'll explain why in further lessons. Also, the Earth, and this comes from plate tectonics to a large extent as well, the Earth seems to have just the right amount of carbon for life, but not enough for runaway greenhouses. What's the whole problem right now with global warming? What we've been told is global warming. It's the loss of it's this greenhouse effect and the increase of hydrocarbons in the atmosphere. And that's real if it occurs. But right now, we seem to have just the right amount. Not too much, not too little. Enough for life, but not enough for this greenhouse effect. So we seem to have very few giant impacts, asteroids and so forth, to destabilize our universe. The atmospheric properties of Earth maintain adequate temperature for plant life and animal life. And we seem to have the right kind of galaxy in the right position in the galaxy. We're not in the extreme center or the extreme edge. Our Earth allows for complex plants and animals to exist. We have just enough photosynthesis to produce oxygen. And we're going to stop there. So next week we will look at the privileged planet and also a little bit of Hugh Ross's book, The Creator in the Cosmos, and then get into maybe just not a lot of detail, but just a little more detail of why Jupiter, why the moon, why plate tectonics. We can't look at all these factors. We'd be here for years, literally for years. And I don't want to do that, obviously. But we're going to look at about 4 of these things that point to why life is able to exist on Earth and why that's such a rare thing, and probably not common in the universe.